Alright, what's up guys? In this video I'm going to pick up some vector calculus. We're going to be evaluating another line integral here. So we're asked to evaluate this line integral xy minus 4z ds, where c is the line segment from the following point to this following point. So the first thing that we need to do is to parameterize the line segment. So that's the first thing we need to do. Now remember how we do that. That's just going to be r of t is equal to 1 minus t multiplied by x sub 0, y sub 0, z sub 0 plus t multiplied by x sub 1, y sub 1, and z sub 1. And remember that t in this case will be in between 0 and 1. So we'll go ahead and parameterize the line segment. So what we'll have is r of t is equal to 1 minus t multiplied by 1 comma 1 comma 0. And then this will be plus t multiplied by 2 comma 3 comma negative 2. And what this is going to do is to give us the parametric equations. So it looks like we'll get 1 plus t, 1 plus 2t, and then it looks like we'll get negative 2t. And so therefore we say that our parametric equation for x is 1 plus t, parametric equation for y is 1 plus 2t, and then the parametric equation for z is negative 2t. So now we evaluate the line integral, and this can be a line integral in R3. Okay, so remember that's just f ds is equal to the integral from a to b, and it's going to be f of x of t, comma, y of t, comma, z of t, multiplied by the square root of dx over dt squared plus dy over dt squared plus dz over dt squared, and integrated with respect to t. So that's the formula. And we just got to go through and do everything. Alright, so the first thing we need is our derivatives. So we need dx over dt. All we got to do is look at the parametric equations, and it looks like we get 1. Then we need dy over dt, and it looks like we get 2. And then we need dz over dt. In that case, we'll get negative 2. Now we need the magnitude, because that's what the ds part is. So we need the magnitude of r prime of t, which is just the square root of the sum of the components squared. And so in this particular case, oh, by the way, let me just do it this way. So that way you could, so that's going to be 1, 2, and negative 1. When we took, or 1, 2, and negative 2, when we took the derivatives. So now we get 1 squared plus 2 squared plus negative 2 squared. And we continue. So this is going to be 1 plus 4 plus another 4, which is the square root of 9, which you know is just 3. So that's ds. ds is 3. And we just got to deal with the line integral now. So we got xy minus 4z ds. It's going to be from 0 to 1, and we just got to stick the parametric equations in and whatnot. So we'll get 1 plus t, 1 plus 2t, and then this will be minus 4 multiplied by negative 2t multiplied by 3 dt. So if you've got it set up like that, you're good to go. Now we simplify it a little bit. So we can pull the 3 out to constant from 0 to 1. And if we simplify on the inside here, it looks like we're going to get 2t squared plus 11t plus 1. And that's integrated with respect to t. Okay, so if we integrate from 0 to 1, 2t squared with respect to t, we'll get 2 over 3. If we integrate from 0 to 1, 11 t with respect to t, that'll be 11 over 2. And then if we're integrating a constant, this 1 here with respect to t from 0 to 1, that obviously just gives us a 1. So now we simplify the inside here. So it's 2 over 3 plus 11 over 2 plus 1, which gives us 43 over 6. So this is going to be 3 times 43 over 6, which we know reduces down to 43 over 2, which would actually be your answer. So your final answer, we evaluate this line integral xy minus 4z ds. The answer in this case is 43 over 2. Alright, so relatively straightforward, I hope. Like I said, I've done plenty of examples on them, so. Alright, well, let me know if you got any questions about how I got my answer. I'll be happy to explain it. Alright, I'll see you next time.